If you like the channel and if you want me to keep going, please subscribe to my channel, give it a thumbs up. I'll keep making these videos. And today we're going to continue with interfaces. So as per the last example that we spoke about, I had looked at employee and payable interface test, and now we're going to use the commission employee. And this is where the polymorphism comes in as well, because we use new commission employee and we have here 3 strings, an integer and a double. We have here two strings, an integer and a double, and it automatically, we're programming in the general, remember, so it automatically knows which one to choose, which constructor to use, and which thing that they can pull from. Also to note that, for instance, because commission employee uses the get string from employee, if I just go down here, if I was just use the default implementation of this, which is super.toString, there we go, and then run it again, it's not going to work actually because I have to do some stuff here, because I was going to just show you how to implement these. 1 second. So now we should be working. Maybe not. Let's see. Yeah. So here you can see here in the commission employee, it's not going to show up the first name or the second name or anything else within the employee that it was there. So the employee toString had, let's say if I open it up, the employee toString method had nothing in it, but here we already know that it's toString here, and if I go to this definition of it, then it's just converting it straight to an object. So we already know that commission employee then appears as a toString representation, so it just comes up as commission employee, and then payment due is coming from the toString here with get payment and payment due as well, which is part of the get payment amount. So then we have other things to look at as well. So I'm just going to put this back. So then once we do the test again, it just shows you that it comes up with first name, last name, and the PPS number. So these 3 are coming, well, 3, 1, 2, 3, 4 are coming actually from employee. So if I look here, 1, 2, 3, 4. So get first name, get last name, and get SSN, and that's coming from the employee toString, which inherits from objects. So we override the method then. You cannot override final methods. That's one thing to remember, because it guarantees that the final method implementation will be used by all direct and indirect subclasses in the hierarchy. So the methods that are declared static are also implicitly final. Remember this, because they can't be changed basically. So a final method's declaration can never change. So all the subclasses, so commission employee to employee, for example, can use the same method implementation, and calls to the final methods are then resolved at compile time. So that's called static binding. So we also have something called the principle of least privilege, which I've spoken about now a couple of times, and that's where you use the final keyword comes into play. Here there's 2 different reasons, well, there's a couple of different reasons why we would implement an interface over an abstract class. So that's the wrong word. We're creating an interface instead of an abstract class, because you use an interface instead of an abstract class when there's no default implementation to inherit. So if you think of an abstract class, which is employee, you think of it as like the general blueprint of what's going to be used. So we have employee, and then every employee, no matter if it's a commission employee, a base plus commission employee, or any other type of employee within the organization, always has to have a first name, last name, and social security number. And that is the reason for it. It's great organization within it, with the abstract, with no intention of creating an object to it, but using those methods with as a result. So obviously with the final here, the other thing that we are using final, and I mentioned it in the previous video, is that final here we have only getter methods, so only accessor methods. If I want to use a mutator or a setter method, it can't be done. So here then we have our implementation. So we have our payable objects, and we don't create a new one. Also to remember is that these are a comma separated iterator list of an array of payable objects, and then we go through that using the enhanced for loop as usual. So with interfaces then there are a couple of five different things that you can also implement. So interfaces implement inheritance extends, okay? Because with an interface, you're just using abstract methods within it. So here we have a public abstract class employee, and then here I'm just going to take that off again. So you can see here we can have a list, and this serializable comes from this java.io package. There's also runnable, GUI, initialize listener, and auto closable, which is really used quite often within Android actually. And then there's also comparable. So with comparable, really cool, because normally we'd use for primitive types, we have int, char, byte, and all the others, and we can't usually compare. We can use them with the operators, so the less than or equal to, or less than sign, or these operators that we've spoken about, the comparison operators. But if we want to compare actual objects, then we use another interface called comparable. So basically with interfaces, the main thing is that they're unrelated classes, but we want to use a lot of the things within them. With serializable then, you have to assign a serial version ID to the class that you're going to make serializable. So this is known as a tagging interface, and it's also, I'm just going to delete that. So you can implement as many interfaces as you want, but you can only extend or inherit from one. So here, now I'm going to delete these as well. Oh, yes, I don't want this either. Now, so I have employee implements payable, and then so you can actually have employee extends and then one class and then implements multiple interfaces. So then the other thing to remember is well, the reasons behind why you would use a abstract or these kind of things. So adding methods to existing interfaces is also a good thing to be able to do, but any class that implements the original interface will not break when a default method is added, but the class simply receives a new default method. So I will declare it as abstract and then sign specified by the interface. And that's basically like signing a contract. So that came in with Java Standard Edition 8. So we have interfaces then and abstract classes. So an interface was typically used when there are no implementation details to inherit. So with no fields or no method implementations. And you can see here in Payable, there's no fields or any method implementations. It's just using an abstract. So with default methods, you can instead declare common method implementations in interfaces. This gives you kind of more flexibility in the design of it. And because a class can implement many interfaces, but it can also extend only one superclass, which I emphasized there a minute ago. So with serializable then as well, you can see here when you click on serializable within interface, if I was to say implements serializable here, then you can go to the definition of it. It's in the java.io package, and you can see here that you use two of the main ones that are used are object output stream and object input stream. And what it does is it converts it to byte representation, and then you want to convert it back. So static interface methods then containing static helper methods for working on objects that implemented the interface. So the static helper methods then are implemented interfaces like collection, list, set, and those kind of things. So we'll come to that later. And also any interface containing only one static or one abstract method is known as a functional interface. So this is just a functional interface. So functional interfaces are also other examples are change listener, comparator, or runnable. They're also the other types of interfaces that are there. And then with the other versions of Java that are coming through as well, so Java 9 then had declared other helper methods in interfaces via private interface methods. So there's private constructors, so preventing object instantiation, sharing initialization code in constructors, and then factory methods. But we'll get to that in the next video. So that's it for today. Just wanted to make sure everything was clear within this, and we'll get to more in the next video. Thanks for watching. And again, if you want me to make more, please subscribe to my channel and give it a thumbs up. Thanks for watching.